Now for the formula of heat, we have devised the formula that Q is equal to mc delta T, okay, which is change in temperature. But if I continue to supply heat for a very long period of time, what will happen onto the body? For example, this is a solid and I have given some heat. According to specific heat capacity and the change in temperature, heat given, I can find anything, okay. So if I have given some heat, I can find the change in temperature. But what if I keep giving it heat? Ultimately it is going to melt, because the process of melting is not just a physical process, it's a chemical change as well. Because when the substance is solid, all the atoms and molecules of the body are tightly compacted in bond formation with each other, okay. But when you provide some extra heat from the outside, these bonds break and the atoms and molecules get free. So these free things get free and they can move anywhere. So this is what we say, that if water is being heated up and water gets converted into vapors, the process is simple. The water molecules which were previously in some energy bond with other molecules, the energy has been supplied to them from outside and they no longer need any further bonding, so they can get free in the atmosphere. This is what we practically see, that is the physical process is vaporization. So heat does not have this only formula, there is another formula of heat which is called mL, where L is latent heat. Now what is latent heat? Whenever state of a body changes, the heat is called latent heat. So latent heat as specific heat capacity, even latent heat has a formula. The formula of latent heat is Q upon M, which is heat supplied per unit mass is called latent heat. Now latent heat will have different name. For example, latent heat of melting, latent heat of vaporization, latent heat of condensation, because of various states available. So let's talk about three common states: solid, liquid and gas. These are three states of matter. Let's name the different types of latent heats involved. When solid gets converted into liquid, the process is called melting. Then when liquid gets converted into gas, this is vaporization. Very good. This is vaporization. Then when gas gets converted into liquid, condensation, like vapors to liquid, this is condensation. Then liquid to solid, this we all know, because in summers we all see this is freezing. Now, okay, let me write the spelling again. FR, freezing, okay. Now, what would be the, before going forward, I want to write it right. I thought I made some mistake. Now it's right, freezing. Okay, so solid to gas, the process would be, name it, this is called sublimation. When solid directly gets converted into gas, this is called sublimation, whereas gas can also get converted into solid straight away without going to liquid phase. This is called solidification, or it is also called desublimation, or it is also called crystallization. Have you seen ice flakes, these ice crystals? During snowfalls, you can see ice flakes, what exactly they are. So that is called crystallization. So they are all different names. We'll go by the common name we use in the book, which is solidification. So these are the processes of change of state of a matter, and when the state is changing, we'll be using this formula, which is Q is equal to mL. Whereas when heat is just supplied to a body without changing its state, so it is actually increasing its temperature. In that case, we'll be using another formula, which is mc delta T. So the important point here to be noted is, whenever, okay, wait, first the name is latent heat of melting, latent heat of vaporization, latent heat of freezing, latent heat of solidification, etc. Okay. Now the important point I was telling you about was, what will happen if the process is taking place of what? Conversion of one form to another. The temperature, what will happen to the temperature? There will be no change in temperature during the process of change of state. So consider a graph of this side I am providing heat, whereas this side I am noting down the temperature, okay. Let us say we have some ice ice crystals or some ice body, okay, at minus 10 degrees Celsius. So when I'll be giving heat to minus 10 degrees Celsius of ice, here we have ice, what will happen? The heat will increase its temperature and it will reach to 0 degrees Celsius, but it has taken some amount of heat, okay. So this is how the graph will go. Now we'll have ice at 0 degrees Celsius. Now any further heat is going to change the state of the ice. So that means after this the state will change and the temperature will remain constant. That means up to this point we have ice at 0 degrees Celsius, wherein this case we have water at 0 degrees Celsius. So before increasing the temperature of water, the whole ice melts into water, and the formula applied here will be Q is equal to ml, whereas see the temperature remains constant here, whereas here if you want to calculate how much heat was given, the formula would be mc delta T. Delta T here would be from minus 10 degrees Celsius to 0 degrees Celsius. This is 10 degrees Celsius. Now when complete ice is melted with water, then if I'll supply more heat, the temperature of water is going to increase. So this time the temperature will reach up to, right, it will reach up to 100 degrees Celsius, and when whole part of water is converted into 100 degrees Celsius, it will start changing its state phase again, and this time again it will undergo the process of vaporization. So from here we have water, here also we have water at 100 degrees Celsius, wherein here we'll get steam at 100 degrees Celsius. And now if we provide further heat, the temperature of steam is going to increase, okay. So from here to here, if you want to calculate the amount of heat, it will be given by mc delta T, whereas here amount will be given by m into L. Again here it will be given by mc delta T. So whenever temperature is increasing, the formula would be mc delta T. Whenever state is changing, the formula would be m into L. But you have to keep one thing in your mind, that here specific heat capacity of ice was taken, and here specific heat capacity of water was taken. Here specific heat capacity of steam was taken. So we have different substances at different points. That is why accordingly we are going to take the specific heat capacity. Same is the case applied for L. Here this is L is the latent heat of fusion or melting. This is latent heat of melting, whereas this is latent heat of vaporization, and then something else. So L is to be taken as situation, same way C is also to be taken as situation.